So we go for the orbital picture of COOH. So in that R, a single bond of O and OH are connected with a sigma bond which is having a shape of trigonal. So the shape is trigonal, and the pi bond will be above or below the planes. This is a plane. This is a plane. C single bond, O is nothing but a plane. In this plane, above and below a pi bond with orbital or a pi bond is there. So the carbon which is attached with alkyl group, OH group, and O is nothing but a sp2 hybridized carbon. So next one, the resonance structures of our RCOOH. So generally H is having a property to relieving as a proton. H is having a property to relieving as a proton. So it produces a RCOO minus. So RCOO minus have it produced RCOOH, in which H is relieving as a H plus. So it results in a RCOO minus, that is the bond between O and H is break up with a heterolytic cleavage. So H is relieves its electron with the oxygen. So the oxygen which have a minus charge. So next we go for the resonance structures, how it will be. So in that R is connected with C, a double bond O and single bond O minus, where the H is relieving as a H plus. So that electron is along with the oxygen itself. So it has a negative charge. Then what happens? This negative charge form a bond, and this double bond is again go to the as electron pair and results in this kind of structure. So starting as R single bond C with double bond O and O minus. This O minus, the electron pair again produces a double bond with the carbon, which, as you know, wherever keep in your mind, wherever R C double bond O is there, it always considered as R C, a partially positive charge, and a double bond O where a partially negative charge. Due to the electronegativity of oxygen, it attracts the electron pair and converted into R minus, converted into O minus, converted into O minus. So as like, so there again resonance structures will occur in this, and then it return as R single bond C with a single bond O minus, single bond O minus, and partially break up and formation of bonds. We can write it as a dots. Okay, so this is due to a resonance effect. The pi orbital or a bond is delocalized between two oxygen atoms. Keep in your mind, the resonance effect is delocalize the pi orbital between two oxygen atoms. The next one is nomenclature. In that we can divide the carboxylic acids into aliphatic acids and aromatic acids. So we classify the acids into aliphatic and aromatic acid. So some of the aliphatic acids are R group is nothing but either H or alkyl group. R is nothing but either H or alkyl group in aliphatic acid. So I gave first one as a HCOOH, which is the common name for that is formic acid, and IUPAC name is methanoic acid. So the name is written as a NOIC. IUPAC name NOIC. If it is in a common name, we can write it as NIC. So we come for the first one formic acid, second one acetic acid, and third one is Propenic acid as for the common name, and IUPAC name is propanoic acid. So O is the difference between the common name and IUPAC name, and we go for the aromatic acid, the second classification, that is C6H5COOH group. So we can write this group either as a C6H5COOH, so which is otherwise called as a benzoic acid or benzene 1 acid. So numbering is comes under IUPAC name. Numbering is comes under IUPAC name. So you can write it as a benzene 1 acid. As the properties, so in that we go for the physical properties, that is physical properties of carboxylic acids. Physical properties of carboxylic acids. In that first one, state. The first one is nothing but state. In which state it occurs? So it occurs as or exists as a dimer in liquid state. In a liquid state, it exists as a dimer. Dimer means two molecules are attached each other. Two molecules. Dimer means a dimer consists of two molecules. So two compounds. Two is otherwise called as di. So two molecules are connected with each other by a intermolecular force, that is a hydrogen bonding. You see, a hydrogen bonding, as you know the first chapter, H is between two oxygen. H is between axis. H is acts as a bridge between two oxygen, that is two electronegative atom. It's called as hydrogen bonding. This hydrogen bonding is a one type of intermolecular force. So it acts as a dimer. So this consists of two molecules. This is one and this is second molecule, which are connected with the hydrogen bonding, up to 6 carbons, that is 6 carbons means hexanoic acids. They are in a water miscible. They are water miscible up to hexanoic acid. After that, there is large number of carbons means containing acids means above hexanoic acid, that is heptanoic acid, octanoic acid, nanoic acid, decoic acid are having a low miscibility with water.